you have to really struggle, I think, to believe that you actually live.
This is the Dash Neural Studio session. So we'll look at the Dash editor and designer and use it to edit your neural networks.
Mathematical analysis of nature.
So to recap the last session, in the previous session, we discussed the MIT 6001 Lecture 1A. So that forms a very basic framework for understanding languages, especially programming languages. Then in that session as well, we looked at the neural syntax. So actually in the previous session was the neural dev session. So what we'll do is we'll take a part of that session and put that into the neural 102. So if you haven't seen that session yet, I recommend that you go to the neural dev session just so you have an understanding of neural syntax. Then in 102, we had a quick look at the comparison between the neural and Lisp mechanisms. So it compares the primitive types, the method of combination, and the method of abstraction of these two languages. Then we also looked at neural patterns. So how do we implement inheritance? Just a second. Mommy. We looked at how we implemented inheritance, instantiation, and properties in classes as well. So that's just a quick go through of the previous session. Now, what are the objectives of this current session? So the first objective, which is the mystery game, we'll skip that for now. Unfortunately, there aren't too many of us at the moment who are available this Saturday. So I guess we'll skip that for another session. Maybe we'll just do a specific session for it. So there's a very important segment in MIT 6001 that is very important to neural. So that is the hint to what the game is about. So we'll just do it at some other time. Then we have already discussed the neural architecture in the neural dev session. So in this session, since this is just a raw version of this neural 103, we'll skip that. I just recommend you to go back to the neural dev session for more details, but we'll go through it here, not really skip it. We'll go through it here very quickly. So it's a very high level rehash of what was discussed. Then we'll set up the Dash Neural Studio. So we'll see how we can download, set it up, and set up an account. So you're able to obtain the beta version of the Dash Neural Studio. Then we'll go through the user interface of Dash. So we understand the different parts of the user interface and how do we use it to update our neural network. Then the last point as well, we'll skip a bit of that because that was already discussed in the neural dev session. However, in the more refined version of this session, we'll go through one by one. You know, the samples that were used in MIT 6001, we'll use those as a basis to formulate our neural network. Okay. Right. So before we begin, as part of our tradition, I'm showing you here a very relevant quote from Gottfried Leibniz, who is a German polymath and one of the most important logicians, mathematicians, natural philosophers of the Enlightenment. He lived around the 17th century, 18th century, and he was popular in the sense that I think he developed calculus separately from Isaac Newton. I'm not really sure about that fact. I'm not sure if it's a rumor or it's something that really happened. So you might as well check Wikipedia for that to be sure about that. But he's a very important figure during that time. And he was the one who said that a universal language or a universal character is important. And you can just go to the Characteristica universalis article in Wikipedia and you will see all of the discussions, all of the notes that he had for this idea. So in this quote, so I'll just let you read what's on your screen. I'll give you maybe some time So just have a read. Okay. So in this very relevant quote, he basically mentioned the three things that we're looking for in neurUL and what we're able to achieve in neurUL. So the first item here, I'll just turn on my pointer. So the first item here, if you remember in the first session, refers to the primitive types. Actually, the second session, neurUL 102, this is the primitive types. We basically need the primitive types. Then the combination, linkages, how we are able to achieve linking. And finally, abstraction, how we're able to define meaning without going deeper, behind what every term or concept means. So it enables us to define, and then as the user wants, they'll be able to go deeper into each definition as they need to, without the need for external dictionaries, because the network itself allows us to define the contents of the network. So this is, in a sense, what we're saying is your brain is actually a dictionary of dictionaries. So it's all multiple hierarchies and levels of definitions and abstractions. Okay. So Gottfried Leibniz at his time was the only one, unfortunately, who was looking at this technology, who was thinking that this is possible. And you will see in the article in Characteristica Universalis in Wikipedia that at different stages of his life, he was very optimistic, and he was getting less and less optimistic about it. And near the time of his death, he somehow gave up. And it was sad because in the quote that he said was that maybe during his time, humanity was just not mature enough, to get their hands on this technology. And I think now we are mature because we have the technology to support this language, and this may give us a reason to work on neurUL, because that's, you can think of it as, let's just do it for Leibniz. He had a very big picture view of what it may achieve for us. One is clarity and reduction of confusion. So if everyone had a complete understanding, and there was no confusion because everyone had a common definition somewhere, then possibly there will be less conflict. So yeah, so I could say that let's do it for Leibniz. Right, so the mystery game, we're not going to play that today. Unfortunately, although there are 5 of us, or 6 of us now. Actually, let me see. Sean, Dipali, if you can just unmute your microphone.
Hello.
Hi, Dipali, how are you?
I'm good. How are you?
Good, not bad. Glad you could join us. And Sean, if you can, I'm not sure if Sean has a microphone though.
Hi.
Hi,
I
Sean.
have it.
Cool. Right, so just wanted to ask if you guys were able to go through the 6001 video, because that's the basis of the game that we're planning to have today.
So I haven't finished it yet.
You haven't finished it. Up to what timestamp did you reach?
And just in the intro, just the introduction.
Okay. Then we might as well play it separately.
Okay.
That's
sure.
better.
I just listen.
Okay, all right, no problem. All right, so yeah, let's play that at a separate time, or maybe we can just do it via the Slack channel. So there'll just be a specific time, and then I'll just post a question there, and it's just a matter of, racing, and whoever is able to answer that question first, then will be the winner of this very nice Google Cap. So I apologize if it's not what you expected, but this is what we can afford for now. All right. Okay. So, right. So the neural architecture is composed of these parts. So in the server, which is hosted in your machine, so this is a Docker container. which can be hosted in Windows for now. That's what I've tested it with. So this is a set of containers. This is a Docker container that is running on your machine. Then it will have multiple containers running inside the Docker server, inside your server. So the first one is the identity server. So this is a work in progress. And this will be used to identify you as the user and to ensure that there are no unauthorized users accessing your avatar. Then the next part is the avatar. This is your body. This is your digital twin, which will contain your cortex, which contains your neurons. Then the graph, which represents your neurons in a graph network. The memory image, which is the spiker. So this is the version of your neurons which can be spiked. So this simulates the spiking behavior of your neurons. So this is just representation, cortex graph. Memory image is the actual behavior of your neurons being replicated. Cognition identity access is the part of your brain which recognizes, which decides the access rights or the capabilities which are available to the user logging into your avatar. So you can say who has read or write access. So you can say your friends are able to read your brain whenever they want to, and so on. So that's cognition identity access. Cortex updater is just responsible for updating your cortex. So of course we'll be having different versions of the cortex. So the cortex updater will be responsible for updating the structure for you. Then you have the organs. So you have, for example, motion sensors, a Facebook logger, a Chrome history logger, which are all running as apps in, for example, your phone, in your laptop. It can be a very small device that's just beside your door, which all sends data to your cortex. So these are like your sense organs or your locomotor organs, right? So let's say someone goes in your door at 12 midnight, then you will have two sense organs. One is for your clock and the other is for your door. And then you will have a locomotor organ, which is switch lights on. So you're able to configure that in the neural network. And you can have as many avatars as you want in your server, right? And it's just up to you how you want to organize your information. Now, the next Dash Neural Studio. So this is the app which will run at your end. So if I just open that here, I'll just open the app at my side. All right. So the Dash Neural Studio is like the browser. So it's like your Chrome browser or editor of your neural network. So this will run on your side, and that's what we will be discussing today on how you install it, how you apply for the account, and then how you run it. Okay. All right, so do we have a volunteer? Can I ask for a volunteer who has a Gmail account? Because we'll be adding that person as a tester or a beta user of Neural.
You can use mine if you want.
Okay, all right. Can you give me your email address, please? In Gmail. Oh, I think you muted your microphone, Michael.
I accidentally sent it to your dad, not to you. Apologies. I just saw Bool and...
That's all right. Okay, so I'll add you there as a new user.
You can ignore that message.
That's all right. Okay, so I've sent you an invite. So what will happen is Michael will receive an invite to our Hockey app platform, which we'll use to manage the bugs, or whatever we need to monitor the usage of our test application.
Got it.
All right. So I think you just need to accept that.
Okay. Okay, so just use Google. You can register an account. You don't have to use Google.
Yeah, great. So you can just use any account. Okay. And then, so what will happen is once Michael is added there.
I have to register first. Okay.
Yeah. So he needs to register.
Okay. Now, so to open this link in my Android or iOS browser.
I think there's a skip part there. Would it be possible for you to share your screen, Michael?
Sure.
Yeah.
Okay, you have to stop sharing.
Yeah, stop share.
And you can run me through it.
Right.
So after I registered with my password, then it comes up with it.
Okay.
So you just go
Then
skip.
you just skip step. Are you running Windows at your end?
Yeah, I am.
Okay, cool. So skip the step. So after he's registered, he skips the step, and then he goes to Dash Neural Studio there on the left. And then download. Right, so just put it anywhere that you can. So it's a disposable copy, don't worry about it. It's a very early version. So everything is running in that folder. So if you want to delete, backup, or make a copy, just copy that folder. So I think you just need to keep.
Okay, Chrome, don't worry about it. It's not dangerous.
Yes. Okay.
Can you download it? No. Let's try again.
Try again, yeah. Oh, that's very fast. And just go to the folder, keep, and then.
Okay.
Yeah. Maybe go to your folder, that downloads folder.
Yep. I've extracted it. Okay, and now?
Can you share your... Okay, I think I can share my side again, my screen again.
Okay, cool.
Yep. All right, so at least we have the steps on how to download it, and go over there. I'll share my screen again. Okay, can you see my screen? Okay. And can you see this folder now that I've showed on the screen?
No. Now, yes.
Okay. Right. So the folder that Michael downloaded is views.wpf. We'll come up with a more appropriate name later on. But so that folder basically allows you to install, to have the copy of the latest neural dash. Now, all you need to do is to open that link, open the dash.exe. So, right. Right. So we're now running the app. So let me just go through the different parts of this interface for you. So when you think of the Dash Neural Studio, you should look at it as if it was a browser. So that's why we have multiple tabs here at the top. So each tab will represent a view of your avatar. So if I'm going to log into my server, or if I'm going to access the neural network in my brain at home, then all you need to do is go to, for example, neural and test, right? So the first part of the address here, so this is the address bar, by the way, right? So the first part of the address here is the address of the server. And we'll go through the details of how you can set up your own server at home if you're running a Windows machine. The Mac version, we still need to test that, but theoretically it should work as well because it's a Docker container. So the first part is the address to my server, And the second part here is the address to my avatar. So I have a test avatar that I'm running, and I can have many avatars as I want, as we mentioned earlier. So once you have the full address, just click on reload, and it should load all of your neurons in this view. So this, if you analogize it to a browser or a web browser, this is the address bar, this is the refresh button, and this is basically all. This is basically your web page. So it shows you all of the neurons in your neural network. And here at the bottom, you will see the status of the last operation, which is reload successful. Okay, so as you can see, it's a very basic, very basic user interface. Now, when you click a neuron, right, it will show you the details of that neuron in the properties window here on the right side. So you can minimize these windows as you want. So if you don't want them, if you just want to focus on editing the neurons, or you can expand it, or you can pin them so you're able to see them. Okay. All right, so this is the properties window. Now here at the top is the graph representation of your currently selected neural network. And if there are any expanded neurons, then those neurons, or exposed neurons, then those neurons will be shown as well. So in this case, if I expand dog by double clicking it, or by clicking the refresh button, it will show you all of the neurons which are related to the dog neuron. So if I click it again, or if I select one of the neurons, then it will show those related neurons and the relationships in the graph. Okay, so whenever you select a neuron here, you will see that it will be selected in the graph as well. So that will aid in navigating. So you know what you're working with and what you're editing. Okay, now if we expand it further, so we can show more relationships. So as you can see, the graph shows you all of the neurons in that root neuron, right? And if I select, let's say I'm analyzing this network here, if I click one, that would be, the background color of that neuron will be changed to yellow, and the same neuron with the same identity will be highlighted in yellow as well in this list on the left. So you can think of this page as the main editor window, right? So you can use your editing activities. You can use this as the basis of your editing activities. So this helps you look at the neurons in a list or basic tree view that we're all familiar with. So this is like the file system in Windows Explorer, right? However, this view here allows you to see your neurons in a graph mode, so you can see how all of your neurons are interrelated with one another. Yeah, so any questions so far? Is it clear? And is the way I'm explaining the different parts understandable?
So far, so good.
Cool.
So here's a question. So they repeat, because so I'm in here now having a look, and so see how you've got dog up there, right? As like I guess a top level neuron on the left hand side. Yeah. Right. But then if you look under poodle and under robot poodle, you also have dog and you have all those. Is that because it's just you're looking at the relationship between those neurons in a different way, right? So the first one is like you're interested in dog, but then it's showing all the relationships,
exactly,
all the neurons that are related to dog, like dog at the top level. But obviously that dog neuron is within the poodle, the poodle one, right? Yeah. But if you wanted to look at the poodle, then you're kind of looking at, you're looking at all the relationships to poodle, which dog just happens to be one part of that. Is that correct? What you repeat all the time?
That is correct. So that's a good question, because I need to explain why it has underline, and actually some of them don't have underlines as well. So yeah, it's a good thing that your question actually reminded me. So basically, whenever you're expanding a neuron, it will show you two things, two types of neurons. First type is postsynaptic neurons. The second type, without the underline, is the presynaptic neuron. So if you look at dog here on the right side, dog has two postsynaptic neurons, which is animal and dog, and sea dog. And if you look at sea dog, if you look at dog again, it has one presynaptic neuron, which is poodle. And as you can see, it doesn't have an underline here. So no underline means presynaptic. With underline means postsynaptic. So if I expand poodle, it has two postsynaptic neurons, cat and dog. So you can see with underline, cat and dog, and one without underline, which is a presynaptic of poodle, which is robot poodle. So every expanded neuron shows you all the related neurons to it again and again, regardless of how many times you expand it, as you observed, Michael. Okay. All right, is that clear? Cool. All right, so now that we understand how it works, if I select a neuron here, it highlights two things, right? So if I click a neuron here in the graph, it highlights the selected neuron in the graph with yellow, and the same thing with the neurons in your editor, in your main editor pane. The postsynaptic neurons are colored in light blue. The presynaptic neurons, sorry, are colored in light blue, and the postsynaptic neurons are highlighted in light green. So if we expand this further, and this really helps when the neural network gets more and more complicated, because it gives you an understanding by just a quick look, what are the postsynaptic neurons and what the presynaptic neurons in an example. Okay. Now that we know how to expand our relationships, we will look at the lines, the terminals, and what they represent, right? So we touched on this very briefly in one of the previous sessions, but we'll go through it again so it's clear. So there are three types of lines that you can see here, right? One is a continuous line, one is a red line, and one is a broken line, right? So the continuous line represents a relationship which has a strength of 1. So that means that when you spike this neuron, the postsynaptic neurons are spiked, right, without requiring any further spiking. If it is a red, then that means that the postsynaptic neuron has an inhibit behavior. So the terminal has an inhibit effect on the postsynaptic neuron. Okay. Now, if you look at this cat, this line means that there is a strength of less than 1, which is in this case 0.5. So that's why it has a broken line. All right. So this means that cat, when it receives a signal from poodle, so cat, when it receives a signal from poodle, will only receive half of the required spike to cause cat to spike as well. So just a reminder, spike is synonymous to action potential. Right. Cool. So that's how you interpret the graph. Now let's look at how we can edit the graph. So let's say we want to add another type of animal. So let's say we want to add a bird, right, as another type of animal. Then before you're able to edit the neural network, what you need to do is to declare your identity. And this is where the identity server comes in. Ideally, we shouldn't need to configure this. Once you log into your avatar, this should be automatically handled for you. But basically, you need to say who you are so that when you do a review, or if you want to see the people who are responsible for the changes in the brain, let's say you use this avatar for collaboration at work in the future, then you need to declare who the user is, so you know who made what changes. So select Elmer Bool, which is the neuron I created to identify myself, right? So that's me. And in this status bar, you'll see who's the author, who's currently registered. And then only then can we make changes to the neural network. So if we click add, we'll then be asked for the tag of the neuron. So let's say bird, right? And then it will add the bird at the bottom. Now, if you want the animal to have a presynaptic neuron, then we can either add presynaptic here, right? Or we can add a postsynaptic from bird, right? The thing is right now, we cannot add a presynaptic. We can add a presynaptic from scratch, but we cannot link an existing presynaptic. So that's something that we need to develop. This is just a small change there. But to be able to associate animal with bird, then we just say, right, we want bird to have a postsynaptic of animal, right? So all we do is go to bird, click add postsynaptic here, and then select animal, right? And then when we do that, it will ask us for the parameters, right? So we'll not go over the details now, but if you click OK, it will use, if you click cancel, actually, or OK, if it's empty, then it will use the default value. So if we say cancel, it will refresh bird. Yep. And then here, we just need to refresh animal, and we can see that bird is already here. There's another way of adding a presynaptic, which is by adding it directly. So let's add another type of animal. So let's say crocodile. So we're adding a presynaptic tag. Just use cancel to use the default values. And wait for it to refresh. So what it's doing is, it's sending the command over to my brain at home, and then it refreshes the graph for you and adds the neurons for you. Right, so that's how you can add a presynaptic neuron. Now let's create a postsynaptic relationship. So animal is a type of a creature, right? So if we're going to add a creature, and since we don't have creature here, that neuron should first pre-exist. So we're going to add a neuron from scratch without any relationship to an existing one. So create a neuron. So this button, by the way, is to create a neuron from scratch. So this is when you want to add a neuron which is not related to an existing neuron. So that's why we now have creature here. And then now we just relate that to animal, to creature. So if you want to add multiple postsynaptic relationships, so for example, creature and then tiger at the same time, then you can just press Control and select the other neurons that you want to add. Okay, so in this case, just select creature, and then that's it. So now animal is a type of a creature. So you can have different creatures that you want to add. So it can be plants, it can be whatever type of creature you want to add to this brain. Okay, so we know now how to add postsynaptic and then presynaptic neurons. Then if you want to delete a neuron, then you can either delete a root neuron or just delete an item from here. Now, there are two types of deletes, right? If you delete a neuron here, then this neuron will be completely deleted from your brain. It will be gone, right? But if you just delete a neuron from here, from under a root neuron, then it will only delete the relationship, right? So you need to remember that. Those are two different types of deletes, right? As if you delete from inside a root neuron, then that just deletes the relationship with that neuron here. Okay, to completely delete a neuron, you need to delete from the root. Okay, now let's create a new type of relationship. So let's say robot poodle is a type of a creature. Let's say robot poodle is a type of a creature, right? Now, there are two different settings. We'll be updating this user interface very soon. At the moment, it's very raw. But there are two things that you need to remember here. Effect has two possible values, right? 1 or -1, okay? If it is 1, then it will be excitation. So as you can see, the black color we have here. If it is -1, then it is inhibition, which you can see here. So for this example, let's just use -1 to indicate that robot poodle is not a creature. It's a technological invention. So we're going to say that it's not a natural creature. Now that's to inhibit, -1. And then the strength. So the strength is a float value. So it can be 0.5, 0.3, or 0.2. So in this case, we'll just use 0.2. Just make sure that you separate both values with a comma and click OK. So what will happen is it will refresh robot poodle. So you can see here, robot poodle now has a relationship to creature. If we expand creature again, we'll restore the previous relationship that we were looking at. So as you can see, it is inhibiting the excitation of creature with a 0.2 effect. All right. Cool. So just wanted to remind you that this is a recorded session. So if you would like to review, if you think you wanted to clarify it further, just feel free to go to the recording that I'll post after a while. And you'll be able to review this whole introductory session on YouTube. All right. So are there any questions? Was there something that you think I needed to clarify about the editor? Cool. All right. So yeah, so that's the neurUL Studio. And the goal is to enhance this further as we go along. Very soon, what we'll have additional panes here. For example, a compiler which will warn the user if there are any relationships which are invalid. So when you say a robot, a dog is a type of an animal, is a type of a creature, but then there are some attributes to it which make it invalid as a creature, then this brain should be able to warn you. So it's like a logic system and reasoning system for the user. Okay. Right, so that's the user interface. And so as we said earlier in the session, we'll be skipping this as we've already done a couple of examples. In a later version of this session, we'll go into more detail and provide more concrete examples so it's easier to understand. Now, to summarize the session, we didn't play the mystery game, but we'll do that sometime else, maybe in the near future. Then we looked at the neural architecture very briefly, so what's involved in the solution as an ecosystem. Then we ran the neurUL Studio. We set it up, downloaded it, and run it in my machine. Then we understood the user interface, so the different parts and how we use the different controls to maintain and grow the neural network that we have. And again, we'll look into other examples in a later version, which will give us a better understanding of how we can use this designer in a more practical manner. Okay, so what's next in neurUL 104? In the next session, we'll be looking at how we can set up the avatar server. So you can have your own brain running in your own machine. You won't be dependent on another server to run your avatars. Then we'll look at the initiatives or the roadmap that we have briefly discussed in the dev session. So one is the metalinguistic abstraction. So we look at how we can enhance and refine neurUL based on the MIT 6001 course. Then we look at how we can use neurUL for the English language. And the thing is that I'm currently updating this neurUL editor so that it has a spiker section. At the moment, the spiker is in a separate version of the application. So I'll be integrating it here. So you can spike directly here and you can see the behavior, the spikes happening in this designer, in this editor. So that's what I'm working on at the moment, hopefully to finish that before the next session. Then we'll look at the basic organs that we've done so far. Maybe we'll do it in 105. So this is a working prototype that we have at the moment. So let me know anytime if you'd like to have a copy of that so you can play with it. You basically need this heart rate monitor from Polar, right? So just a Polar Bluetooth heart rate monitor. And then once you have that, we'll pair that with your laptop Bluetooth, and it will spike the heart rate values in the neural network and then come up with responses for that. So maybe we'll discuss that in neurUL 105. And yeah, that's it. That's it in the neurUL 104. So thank you. Thank you for joining us today for neurUL 103. Right. Are there any questions, clarifications?
Oh, good.
All good. Okay. Thank you so much for your time. See you in the next session. Thank you for joining us this Saturday.
Okay, thank you.
Bye. Bye. Thank you.
Bye.
Thank you, Sean. Bye.
Okay, bye-bye.
Okay. Thank you. Bye-bye.
Okay. See you next time.
The implication reality is made of language, then what we're saying is that it's code. And if it's code, then it is far more deeply open to manipulation than we ever dared dream.